Welcome to your deep dive. Today we're going to be taking a closer look at the world of electrical work,
Yeah.
specifically the hazards electricians face on,
hmm
a daily basis.
Yeah.
Um, a lot of people are probably already pretty familiar with electricity and, the basics,
Right.
but we're going beyond just flipping a switch.
Oh,
We're
yeah.
going to be exploring the raw power of electricity
Yeah.
and, why safety is so important in this field.
Yeah, you're right. Even seemingly straightforward tasks can become dangerous quickly if the proper precautions aren't taken.
Exactly.
And that's what we're really going to be focusing on today. Giving you a better understanding of those hazards and how to mitigate them.
Yeah, and we've got some pretty interesting sources for you today.
We do.
We're going to be looking at some technical manuals, safety standards,
Mm-hmm.
and we even have some real-world case studies.
Yes.
So consider this your insider's guide to electrical safety.
Absolutely.
Mhm.
We'll be focusing on the big three electrical hazards.
Yeah.
Electric shock, arc flash, and arc blast.
Okay, now I think most people have heard of electric shock at least,
Right.
but arc flash and arc blast, those sound pretty intense.
They are.
Can you kind of break down what makes each of these hazards unique?
Absolutely. So with electric shock, you're dealing with direct contact and the path of a current through the body.
Right.
But arc flash and arc blast, those are explosive releases of energy that are caused by electrical faults.
Okay.
Imagine like a sudden burst of intense heat, light, pressure.
Yeah.
That's the danger zone we're talking about.
So let's start with electric shock.
Okay.
I know it's more than just voltage, right?
Right.
Like, what are the factors that determine how dangerous that contact can be?
Yeah, so it's definitely more nuanced than just voltage alone.
Okay.
Um, imagine you have a current flowing hand to hand. If
Right.
it goes through the heart, that's going to be a lot more serious than, if a current passes through your finger.
Right.
So the path that the current takes through your body really matters. The duration of contact matters. The longer the contact, the worse the potential damage.
Yeah, that makes sense.
And even the environment.
Oh, really?
Things like moisture or what you're wearing can make a huge difference.
Moisture, really? How so?
Yeah, so think about it like a wet environment or even sweaty skin.
Right.
That makes your body much more conductive.
Okay.
So that means even a lower voltage could result in a higher current passing through you.
Wow.
The same goes for clothing. If you're wearing non-insulating materials, and especially if they're wet,
Yeah.
that can really increase the severity of an electric shock.
I've always been curious about those situations where, like someone touches a live wire and they can't let go.
Yeah.
Like, what causes that? And I mean, aren't there devices that can, like, prevent that?
There are, and we call those ground fault circuit interrupters or GFCIs.
This, yeah?
And they're specifically designed to detect those imbalances in current flow and shut things down really, really quickly
Oh, wow.
to prevent that kind of prolonged shock. And you'll often find these in areas, near water, like bathrooms and kitchens,
Oh, right. Yeah.
just to add that extra layer of safety, especially in environments where moisture is a concern.
So it's kind of like a super fast safety switch
Exactly.
that reacts even before you realize what's happening.
They're designed to trip much faster than a traditional circuit breaker.
Right.
So yeah, it cuts off that power before a really dangerous amount of current can flow through you.
That's good to know.
Yeah.
Now, what about those other hazards that we talked about?
Yes.
Arc flash and arc blast.
Yes. So think about it this way. During an arc flash, the current kind of takes a shortcut.
Okay.
It arcs through the air instead of following its intended path.
Okay.
And that creates just this incredibly intense release of energy
Yeah.
in the form of heat, light, and pressure.
Wow.
And we're talking temperatures, hotter than the surface of the sun.
It's hard to even imagine that much heat.
Yeah. And with that intense heat, even a tiny piece of copper
Go ahead.
can explode
Yeah.
with, the force of a bomb. Wow.
And that's what arc blast is. It's that rapid expansion of superheated air and vaporized metal,
Wow.
creating a pressure wave that can send shrapnel flying at hundreds of miles per hour.
So it's not just the heat you have to worry about, it's also projectiles.
Absolutely.
So arc blast is a really serious threat.
It is.
And it's why those safety procedures, in electrical work are so strict.
Absolutely.
Speaking of which, we have a case study about an apprentice electrician who was actually killed in an arcing fault.
Oh, yeah.
This might be a good time to kind of dive into the details and see what went wrong.
Yeah, definitely. This case really highlights how even small errors can have just devastating consequences.
Yeah.
So this apprentice was working alongside a journeyman electrician,
Okay.
and they were installing new switch boxes in an office building that was under renovation.
Okay.
And the apprentice was working on a box that was suspended from the ceiling
Uh,
while the juryman was in another room.
okay, so they were working on this.
Right, and that's where the problem comes in.
Yeah.
They didn't de-energize the circuit before starting work.
Right.
So the apprentice reaches into the energized box, cuts the conductors,
Oh, no.
and still holding the exposed wire, he must have accidentally touched the grounded box,
Right.
creating a path for the current to flow right through him.
So even though they were experienced electricians, I mean, a simple oversight like that
Right?
had fatal consequences.
Yeah. It's a really stark reminder of how critical those safety protocols really are.
Yeah, it really drives home the point.
Yeah, this case really emphasizes the importance of establishing a strong safety culture.
Right.
It's not enough to just have the procedures in place.
Yeah.
You really need to consistently reinforce them
Uh-huh.
and make sure everyone understands the risks involved.
It's about creating that mindset
Exactly.
where safety is always the top priority no matter what.
Absolutely. Now, shifting gears a bit, how do we protect against these arcing faults in the first place?
Yeah.
You know, it seems like timing is everything.
When you're dealing with that kind of energy release.
Well, you mentioned overcurrent protective devices or OCPDs earlier.
Right.
Are those kind of the key?
They are, so think of OCPDs like the safeguards of an electrical system.
Okay.
They're constantly monitoring that current flow.
Mhm.
And if they detect a fault, like an abnormal surge,
Right.
they interrupt the circuit,
Okay.
essentially acting as that safety net.
So it's like a circuit breaker,
Yeah,
but on a much faster and more sensitive level.
exactly. And there are different types of OCPDs out there.
Okay.
Some are specifically designed to limit the amount of current that flows during a fault,
Oh, wow.
which is even more effective at reducing the energy released in an arc flash.
Oh, okay.
So the faster they react, the less damage is done.
So the speed of an OCPD's response is really critical.
Absolutely. We're talking fractions of a second here.
Right.
And those milliseconds can make all the difference when it comes to protecting workers from serious injury.
This deep dive is really highlighting how important it is to choose the right protective device for the job.
Absolutely.
Are there any other safety measures that we haven't really touched on yet?
You mentioned personal protective equipment, or PPE, earlier.
Right.
Maybe we could talk about that a little bit more.
Yeah, PPE is a huge part of electrical safety.
Right.
But what kind of gear are we talking about specifically?
Well, it's all about creating a barrier between you and that potential hazard.
Right.
So we're talking insulated gloves and footwear,
Uh-huh.
face shields, and especially arc-rated clothing.
Okay.
This type of clothing is designed to withstand the intense heat and flames of an arc flash,
Oh, wow.
minimizing the risk of burns.
So PPE is kind of like that last line of defense.
Exactly.
But it's not foolproof, right?
Correct. While PPE can drastically reduce the severity of an injury, it's not a guarantee of complete protection.
Right.
It really needs to be paired with those safe work practices
Uh,
and a comprehensive understanding of the hazards involved.
so it's not just about having the gear.
Right.
It's about knowing how and when to use it properly.
Absolutely.
Are there any specific guidelines that kind of dictate how PPE should be used in electrical work?
There are. So NFPA 70E,
Okay.
which is a really widely recognized standard for electrical safety in the workplace.
Right.
It outlines very specific requirements for PPE,
Okay.
covering everything from selection and care of equipment to the proper procedures for, putting it on and taking it off.
So you need to choose the right gear for the job,
Yeah,
make sure it's in good condition.
absolutely.
But how do you actually know what level of protection is needed for a specific task?
That's where a hazard risk assessment comes in.
Okay.
So before starting any electrical work, you need to evaluate the potential hazards,
Right.
including the likelihood and severity of an arc flash incident.
Okay.
And based on this assessment,
Yeah.
you can determine the appropriate level of PPE
Okay.
required for each worker.
So it's not a one-size-fits-all
Ah.
approach. You really need to tailor the safety measures
And-
to the specific task at hand.
Right. And NFPA 70E
Cool.
provides a framework for making those decisions
Yeah,
and ensuring that workers have that right level of protection.
that makes sense.
And it emphasizes a hierarchy of risk control methods, with elimination and substitution
Okay.
being the most desirable options.
Elimination and substitution, what do those mean in this context?
So elimination means removing the hazard completely.
Okay.
So, for example, if a task can be done with the equipment de-energized,
Right.
that's always the safest option.
Yeah.
Substitution involves replacing a hazardous process with a less dangerous one.
Okay.
So maybe you could use remote control devices
Right.
or automated systems to minimize that direct interaction with energized equipment.
So it's all about prioritizing the safest approach first
Yeah.
and only resorting to PPE when it's absolutely necessary.
Right. PPE should be that last line of defense, not the first.
It makes sense.
Yeah, we really need to focus on creating a work environment where hazards are either eliminated or controlled at the source before relying on that protective equipment.
This hierarchy of risk control methods sounds like a really smart approach to electrical safety.
It is.
It's about taking that proactive rather than reactive stance.
Exactly. It's about shifting the focus from simply protecting workers from harm to actually preventing those hazards from arising in the first place.
Right.
Yeah,
This has been a really insightful deep dive.
it has.
It's clear that electrical safety goes far beyond just knowing the basics.
Right.
It requires a deep understanding of the risks involved, a commitment to safe work practices,
Yeah.
and a culture of continuous improvement.
I agree. It's an ongoing process of learning, adapting, and implementing those best practices to ensure that everyone can go home safely at the end of the day.
And on that note, I think it's time for us to wrap up this part of our discussion.
Okay.
When we return, we'll explore some final thoughts on this important topic.
That's okay.
Okay, so we're back, and we were just talking about PPE being kind of that last line of defense.
Right.
But it sounds like it plays a really important role in electrical safety.
It does. It's about minimizing the damage if something does go wrong.
Okay, so can you talk a little bit more about what PPE actually involves, for electricians?
Sure. So the specific PPE required can really vary depending on the job and the level of risk involved. But some common items include things like insulated gloves,
Okay.
insulated footwear,
Mm-hmm.
face shields,
Yeah.
and probably most importantly, arc-rated clothing.
Okay, can you explain a little bit more about what arc-rated clothing is?
Yeah, so arc-rated clothing is specifically designed to protect workers from that intense heat and flames of an arc flash.
Okay.
It's made from materials that can withstand those extreme temperatures.
Okay.
And it helps to prevent serious burns.
So if someone's working on a task where an arc flash is a possibility,
Right.
arc-rated clothing is essential.
Absolutely. It's not something you want to take any chances with.
Now, I know we've talked a lot about the different types of hazards and the importance of PPE.
Right.
But what about the actual work practices themselves?
Yeah.
Are there any specific procedures or protocols that electricians follow to kind of minimize those risks?
Definitely. One of the most fundamental safety practices in electrical work is something called lockout tagout.
Lockout tech?
And it's all about de-energizing the equipment before any work begins.
Okay, so it's not just about flipping a switch. It's
Yeah.
actually physically locking out the energy source.
Exactly. So it involves placing a lock on the disconnect switch or circuit breaker,
Okay.
and then attaching a tag that clearly identifies who's working on the equipment and why it's been locked out.
So that no one accidentally re-energizes it.
Right. It's all about creating that visual reminder that work is being done and that the equipment is not safe to operate.
Okay, so lockout tagout is basically non-negotiable.
Absolutely. It's one of those foundational safety practices that can truly prevent accidents.
This deep dive has really been eye-opening. It's so important to have these conversations
It is.
because electricity is something we all use every day.
Right.
But I think most people don't really understand the risks involved.
Yeah, I think a lot of people take electricity for granted,
Right.
but it's a powerful force.
Yeah.
And it needs to be treated with respect.
Absolutely. So as we wrap up our discussion on electrical safety,
Yeah.
are there any final thoughts or key takeaways that you want to leave our listener with?
I think the biggest takeaway is never underestimate the power of electricity. Even something as simple as a residential wiring job
Right.
can turn dangerous quickly
Yeah.
if the right precautions aren't taken.
Yeah.
And one of the biggest mistakes anyone can make
Oh.
is assuming a circuit is dead.
Yeah.
You always want to verify that it's de-energized.
Right.
And that means following those lockout tagout procedures to the letter.
Lockout tagout. That's, non-negotiable.
Absolutely.
Right. It's not just about flipping a switch.
Nah.
It's about physically locking out the energy source.
Exactly.
And, we've talked about PPE.
Yeah.
It's essential,
Right.
but it's really that last line of defense.
Exactly.
Right. The goal is to eliminate the hazard altogether.
Yeah.
Or, substitute a safer method whenever possible.
If you can.
So for our listener, if they walk away remembering just one thing from this deep dive,
Yeah.
what would you want it to be?
That electrical safety is a shared responsibility.
Yeah.
It's a combination of the employer's commitment to providing a safe work environment,
Right.
the right training and equipment,
Yeah.
and the workers taking personal ownership of their safety and
Yeah.
then the safety of those around them.
This has been a really electrifying deep dive.
It has.
It's really opened my eyes to the hidden risks
Yeah.
associated with electrical work,
Yeah,
and just the huge importance of prioritizing safety at every step.
absolutely.
So as we wrap up this episode,
Yeah.
are there any, final thoughts on the future of electrical safety?
That's a great question. We've already seen some huge advancements in prolector devices and arc flash detection systems.
Right.
But imagine a future where sensors and predictive analytics could anticipate potential faults before they even occur,
Wow.
automatically de-energizing circuits
Right.
and alerting workers to potential hazards in real time.
That sounds amazing.
It would be a game changer.
Yeah, it really highlights how technology can play such a crucial role
Yeah.
in enhancing worker safety.
Absolutely. And as technology continues to evolve,
Yeah.
I'm hopeful that we're going to see even more innovative solutions
Yeah.
that'll help us create a safer and more secure work environment
Right.
for all those who power our world.
It's a reminder that learning never stops,
It doesn't.
especially when it comes to something as crucial as safety.
Absolutely.
So until next time, stay curious, stay informed, and most importantly, stay safe.